Okay, good. I think my audio is coming through now. Yep, it's definitely coming through on my own system because I've got the live stream running up there as well. Yeah, yep. So, okay, I have some of the subject admins in here as well, and they're wait, Lee Chen said no. My audio is not coming through. Hang on, let me just check. Oh, okay. Ah, good. Okay, people can hear me. That's right. Always a good start. Um, Look, to be honest, I had um, I had the microphone not connected on a couple of things while in that little offline period before, so I was also getting all my stuff set up. Okay. Let's increase the size of that. So we've got. Well, I'm logged into VLab. I'm here, and oh, I can't turn my laptop around, but Tom and Andrew are here, the two subject admins as well. So every time I get something wrong, because the live stream is not as meticulously prepared as my lectures or anything like that, so there's a chance I'm just going to write some code, and one of the two of them will go, "Hey, might be more useful to people if you teach it like this," and I'll be like, "Okay, we'll change stuff." So this is much less organized than a lecture, and much more just me firing off things and banter. So I don't have much prepared for this. I do have a couple of things that I did want to talk about. So some of the things that I think are the most confusing bits of the assignment that I want to cover. But I also thought, I mean, because we've already got we've got like 4 or 5 people who are already active in chat, and we haven't even hit the time that we were going to start the stream yet. So nice to see you here. Actually, anyone who's on the stream right now, because I've got 21 people watching right now, just say hi. Just want to see who's around and say hi. Sorry, every time I look off to the side here, it's me looking at the chat log. I got a second monitor going over there. But other than that, I will be going through some stuff and doing some code as well as some diagrams and things like that, just to help you get a feel for certain things in the course. But mostly, I think it's going to be like, what what do you want to know? So we've got a couple of hours where you can just ping me with things, and especially the timing here is for like you're working on stuff for the assignment. So I think that's the biggest thing that's happening in the course right now. So if anyone's got any questions about the assignment, we can jump straight in with those. So let's start off with open the floor to anyone who's out there who's watching. Do you have any questions about the assignment? Is there anything confusing that you would like me to talk about? I'm not going to do very much in the way of code for the assignment here because I don't really want to like how like I have that whole thing where I say um, I don't want anyone to take anyone else's chance at education away from them. It's like one of my rules, and I can do that by mistake as well. Because if I did the whole assignment on the live stream, I've made that mistake before. You end up not getting a chance to learn it yourself. So I probably won't do that much code. Okay, first question from Josh. Question is, can we change the code where it says that you don't need to change the code? Um, my suggestion for that would be I would highly dissuade you from doing that because there's nothing in that code that actually needs a change. And if you do change that code, you could actually put yourself at great risk of introducing mistakes into code that we've tested really um we've tested really explicitly, you know. So we know that it works in a particular way, and we know we're going to mark assuming that it works in a very particular way. So if you make changes with that, there could be some risk there. So I would say the question will be, do you feel like you need to make a change there? And if you feel like you need to make a change there, sometimes that means there's something that you want to do with the structure of your code. And it could be that there's another way to structure it. I'd actually take that question to a help session or a tutor and like just talk to them and say, this is what I thought I wanted to do when I wanted to change the starter code. And they may be able to give you some advice to take a different approach with what you want to change. And then that may give you a chance to actually look at it and say, oh, there's other things I can do that's actually going to get me the change that I want. So I hope that's enough of an answer to your question, Josh. Um, oh, another thing, Andrew was just pinging me to let me know about this. If you do want to do simple things, like say you have done your entire assignment in one of the two kind of styles, like camel case or snake case, um, if you're changing the way, actually, Andrew, can you put into chat the difference between camel and snake case? Because it's easier if you can see it. Yeah, if you do want to just change the style so that your entire assignment is all in the same style, you can do that if you want. There's no problem with that. Lee Chen is asking, in hollow ellipse, ah, how would you suggest to fill the ellipse before unfilling it if the input is 0? So Andrew's got some info on camel case and snake case. Okay, let's I'm just gonna open up my browser here. I'm going to try to not open anything that you're not supposed to see yet. Assignment 1 stream. Do I have a link to the assignment spec? No, I don't. Yeah. Also, you would have flashed up a link there to the second assignment. Don't worry, that's not your second assignment. That was the second assignment from last term. That's just in our yeah, in our background thing that we can still see. So we tend to leave the last terms there before we replace it. That's not, so don't worry about that. That's not a spoiler. Okay, so we were talking about ellipse drawing. So we're down here into stage 3. And Lee Chan's question was, oh, in stage 4, when it's hollow, how do we fill the ellipse before unfilling it if the input is 0? Not sure I have a full understanding of that, but I assume what you're going to do is you're going to do a stage 3 ellipse where you fill it completely, which is this one. So everything that is inside the boundaries of the ellipse is full, and then your um like so, and then what you wanted to do was do the hollow ellipse. So I assume, and I've got some diagrams here like this. Sorry, I just needed to check on something. I assume what you're asking is that, and you can obviously, like, if you want to, you can say anything you want now to clarify, Lee Chen, that you're going to draw everything here, and then you wanted to say detect which these inner ones are, and then set them back to the background color. Is that, I assume that was the technique that you wanted to do to solve this problem? Yeah. Okay. Um, I think I don't want to go into especially stage 4, because stage 4 is the one where you really want to be. We want to be testing whether you can think about. So, sorry, I just saw that. Based on your reaction, I don't think this is a good way. Okay, let me tell you a story. I had a story of a student. I think it was in term 1 this year, and I was helping them out because I went to one of the help sessions to help them out, and they were typing their code, and they would type a few words of code, and then look at my face, and then they type a few more words of code, and then they look at my face again, and I had to say to them, you're not actually going to be able to learn how to program by just looking at my face and seeing whether I cringe on your based on what you're writing or not. However, um, there is something to that though, and I think it's quite funny because usually you don't get to see my facial expression as big as you're seeing it right now. But one of the issues you might get if you were to fill the whole thing and then unfill the center is, how do you know what used to be in the center? What if there's a whole bunch of lines and different shades and stuff like that in the center? So I'd be very careful with that approach. However, I think you've got the right idea. Is that you definitely need to identify which ones are the ones that aren't going to be drawn. Um, but don't necessarily fill them all in with that color first. So you may not want to do this kind of two-pass thing where you go, I'm going to do stage three exactly as it is, and then I'm gonna do a second pass which hollows out the ellipse after it's drawn, because that could be quite dangerous because you do get this kind of thing where you've already overwritten everything that's underneath. Um, I don't want to give you too much more because I think some of what we're testing. Oh, sorry. Andrew's telling me to scroll down. Oh, and there's more. So these are going to show you exactly the sort of formulas for the decision making on which pixels are and aren't. I need to actually stop scrolling so this just gets a chance to load and show you. Um, these will give you a decent idea, these diagrams, on exactly which things should be drawn and shouldn't. So think possibly about not necessarily doing the whole fill and then unfill, but for everything that could or couldn't be in the ellipse, check whether it's on the edge of the ellipse or not. So there's a few things. So as you go to draw it, you can decide which thing's on the edge of the ellipse or not, and then decide to draw it at that point where you check it. And that way you're only doing one pass as well. So you're just looking at every pixel once, and you're saying the things around it. Do I test those things around it, and do I see whether they're on the edge of the ellipse or they're inside the ellipse? If they're totally inside the ellipse, which is, I think this image up here. Oh, no, no, the one below. Yeah. So this one's entirely inside the ellipse. Then you can be like, oh, yeah, yep, cool. Lee Chen's got it. So yeah, that way you only have to do one pass. You don't have to do a fill and unfill. You can just be like, I have just an extra set of conditions that I'm going to check to decide whether I want this or not. Um, Shout out to Andrew B, who noticed this kind of thing in the ellipse and decided to throw in a few extra diagrams for us in here to just at least make the algorithm a little easier for people to understand. So it's like I'm like a real streamer. I'm doing shout outs and stuff like that. Everyone can donate to this button and send me Twitch coins, and no, we're not doing anything like that. I feel like you've paid enough for this course already. Mm, yep. Okay, so another question, and I think there was more than one person asking this question. Jordan and Zachary. By the way, this this artwork here is for sale. I put it up for sale last year for $5,000. Um, for some reason, no one took me up on this. Um, Someone did offer me, I think, about 50 cents for it, which I think even even at this quality of art was not worth my time selling. but but I like to I like the level of quality that my students expect from me, that they think I'm 50 cents worth of quality here. It's awesome. Okay. Um ooh, there's a question about beautiful code. Okay, where's my Patreon link? Yeah. Okay. Let's go back the questions one at a time, because we're back at Jordan and Zachary were asking about stage three copy paste. Okay, so stage three copy paste. So copy paste uses stage one square drawing to a certain extent. So what it does is the coordinates it gives you is pretty much exactly the same as, well, the first bit is exactly the same as the square drawing, where it just defines a square somewhere on the canvas. And what it wants you to do is to take a square that's somewhere on the canvas and say everything that's the pixels in that square, you will now draw to a square that's somewhere else. So let's have a look at the diagrams here. So let's say we had this square, which is the first set of coordinates, draws this kind of square, which means that we have a set of pixels that is going to be the things that we read from. And then we get given another point, and the point there, I'm pretty sure the target, yeah, the target's only the point. It's not the length and the direction, because it's going to be exactly the same size. Um, and the this is going to be where we're going to write things to. So what we're going to do is basically we have this set of pixels, and we want whatever's in this set of pixels to be drawn to this set of pixels. Ah, okay. So you can define a square. So Jordan's got to the point where you know that this is a square and you know all the coordinates of all of the pixels in that square. And you know this square and you know all the pixels in that square. And the next thing that you want to do is you want to replicate what are the values of all these pixels onto these pixels. Can you think of a way to do that? I feel like if I had two of these defined and I knew that I had two squares, exactly the same number of pixels, then I feel like I could potentially write a function that would go through one set of squares, one set of pixels, and read them, you know, one by one, and then say, this one goes here. So you take the value from here and you overwrite the value here with the value that was there. And then you move to the next one, and then you go, okay, I'm going to read from the value there and write to the value there. Okay, Jordan. Okay, wait. We've got a few questions here. Zachary says, for copy paste, does it have to be a square and not a line like the fill square command? Um, okay, at this level of detail, Tom, are we doing a single line for these if it's a zero angle? Yep. Yep. Okay, Tom's saying that. Mm. So, as far as I remember, square drawing, if it gets a 0 or a 90, like one of the straight line cardinal directions, um, it draws a line, right? Instead of a square, which means these would be defined the same way. So you might get a copy paste for a line. But I think that we're going to be very, very permissive with that in the testing. So even if you can't handle that, you can still probably get nearly all the marks for copy and paste. Because most of the testing for copy and paste is not going to be on the shape of the copy and paste, but whether you can actually transfer things from one location to another. So we're going to test, I think, like 99% of the tests for the copy and paste are going to be proper squares because we've already tested you on the square drawing in stage one. So we're not testing on the square drawing here. We're testing on whether you can transfer data from one part of the array to another. We think about it like that, like that's the kind of thing that we're doing here. We're transferring information from one place to another. And when you think like if we ever asked you to say, take the second element in array and write it into the fifth element in the array, you'd be able to do that, right? Because you just address one part of it, take the value from one part and place it in the other. That's the same thing we're doing here, but we're complicating things for you by saying, okay, could be in any position in this array, in this two-dimensional array. We've got a two-dimensional array. We're moving these squares around in our tests to different places. Plus, it's not just a single element. We're getting you to loop through 2 dimensions worth of elements. So there's a bit of extra there. I mean, like it's stage three. Stage three, we're looking at trying to get distinctions and high distinctions by doing stage three. So it's quite advanced at this point. But really, when it boils down to it, is like read data and write data. So read data from one location, write data to another location. It just so happens they're all inside the same data structure, but still just reading and writing. If I asked you to take the value of one variable and write it into another variable, so it's like take whatever value is in X and write it into Y, I think you could be able to do that really easily, right? This is just like that, but it's all like, it's 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 contained in a whole bunch of other complication that we want you to find a work to work your way through. Okay, is that enough? Information for the people asking about the copy paste. Like obviously I don't want to give you too much. I don't want to tell you exactly how to complete the assignment or anything like that. I think that would be too much. But I think I've told you enough information that you could probably get there, especially because I think who was it? Jordan had gotten to the point where you knew where you were going to copy and paste from, and it's a matter of trying to figure out the technicality. I would try something along the lines of just copy a single square, single pixel to another pixel, and then like try to copy a line to a line, and then you can just loop those things. Like, because even if you can just copy a single pixel to a single pixel, you can then while loop that to copy a line to a line. And then you can while loop that to copy a square to a square. If you go back to my lecture code about just drawing a square and how I built that up from like draw a single thing, loop it to draw a line, and then loop that whole thing to draw a square, you should be able to do this square to square like that. So everything's kind of building up from stuff like that. Um, Okay. Ooh, we've got lots of questions popping up. So I think the next thing that we had that was Messi, oh, Lionel Messi. Okay. Oh, right. Nice. Sorry, I didn't realize that Andrew was actually keeping the track of the questions for me. How to decorate my code? I don't know what beautiful code means. Okay, so this is an interesting question. Sorry, just having my bubble tea. Um, if the best test for your code is how easy it is to read and understand, this is a hard one to work on when you're doing this kind of solo assignment, especially when we're saying to you, you can't share your code with other people. So one of the first things that I would do for something like this would be like, usually I would do something like a code review. I'd show someone else and say, "Can you understand what I've written here?" And the inevitable is usually like, "No, Mark, that it does not make any sense. I have no idea where you're going with that." And you'd be like, "Ooh, okay." So I'm so deep in this, my headspace is so deep in the code that I've forgotten how to make it reasonable to other people. The simple things to do first: make sure your variable names are an accurate and distinct description of the things that you're writing. So your variable names and your function names explain what they are. Like, don't go too long with it, but enough that they explain what they are. And that way, if someone's looking through your code, they can say something like, and like even right here, I'm just looking at this, like start row, start column. So I know that this is where an area or something starts, and these are the coordinates for the row and column. So if I saw the variable name start row, start col, I would know exactly what I'm going for, right? I would know that this is a position on the canvas somewhere, and it's a position that we're starting something. So when this way, I can understand the row and the column, but also the start row, start col gives me this distinction to the target row, target col. So when I'm deep in my while loops and I'm copying one thing to the other, I don't have copy X to A and Y to B or something like that. I have this really nice thing, which is copy start to target. And that's something that works quite well. Um, the other thing I think is nearly the shape of your code. So when we see code that's easy to read and understand, one of the things that happens is the way that we like to read code is in a vertical way, right? Because everything that we do when we're reading code is based on, from your perspective here, the left side of the code. And going down the left side of the code, um, we will always scan from top to bottom and go, okay, this happens next, this happens next, this happens next. The more we have to go and read through along the line to the other end, um, the less chance we have of like kind of keeping track of where we are. And the deeper our indentation goes also, the harder it is to keep track of where we are. So one thing you can do to test whether your code is like really beautiful code is to look at the left-hand column in a sense of your code and just read it from top to bottom. And if you're just reading it from top to bottom and you can fully understand your code without having to scroll left to right, without having to stop and go, well, there's some important information that wasn't on that left hand side, or without going too deep in the indentation and like getting so deep in the indentation that you're like, I don't know where we are anymore, then that's a really nice thing for structure. So we're looking for really beautiful code. It's something that we can just like look down the left hand column and go, okay, I fully understand this. I understand what's happening here. I understand what's happening next. And like there's a whole big complicated thing with like a triple D while loop in it or something like that. But what I see when I'm scanning down the left hand column of the main function is just a function that says complete this thing, right? And so the nice thing is like if we push some of the complicated stuff away into functions, and then we make it really easy to read, we don't go too deep in our indentation. Um, that kind of thing is one of the nicest ways I think to make our code really beautiful. What do you two think? Is there anything else you think that you'd want to talk about for really beautiful code? Sorry, there. Oh yeah, Andrew's like I wasn't listening. So I was like, yeah, we follow down the left-hand column, and that's how we try to see things. Not too deep indentation, not too long lines, sort of structure, naming always on its actual use and things like that. Yeah. Mm. Each line of your code should do one thing. So I see a lot of people, and especially when you look at something like CS Paint. CS Paint has a lot of stuff with a two-dimensional thing. So a lot of stuff where you might be doing multiple if statement checks. The more if statements you join together, the more likely it's actually going to be better to just put them in a vertical kind of column rather than across each other. Because the more they go across each other, the more likely you are to read the first part of the if statement and forget the rest of it. And some of the rest of it might be the most important thing. So the more you push important things away from the left-hand column, um, the riskier it is that your code becomes hard to read and hard to manage. So I think those are the basic things. I mean, I don't really want to teach you everything about how to make code beautiful right here and now because there's so much code left to learn, right? So I think for the moment, um, simplicity of how easy it is to read. I think one of the best tests, and you can actually test this. You can test this with someone who's not in the course. Give it to someone who has no relation to COMP1511, so then it doesn't count as plagiarism. Well, sort of. Still could. No, but this is very bad. But just take it to a relative or someone who's obviously not going to tell anyone else about it. So not friends on campus or anything. Show them the code and then ask them if they can tell what it does. So they might be able to look at it and say, I think it's going to do this, this, and this, and this. And what they might be doing is just reading through your function names from top to bottom. They may not understand how the bracketing works. They may not even understand how what an if statement or while loop is or something like that. But they might actually be able to tell a lot about what's happening. And that's like uh, the ultimate test of your readability is your code so well written that someone doesn't need special knowledge to be able to read it. And that's huge. If you can get your code to that level, that's that's like the 100% of code. So that's the code that's probably going to get 20 out of 20 for style marks. If and our my tutors know that. We know that. Like we're going to look at the code and we're going to scan it and we'll scan it like in this way where we'll be like "duh-duh-duh-duh-duh-duh," and we'll spend like literally 5 seconds looking at your entire assignment. And if we have a full understanding of your assignment with only 5 seconds worth of scanning it, like yeah. Okay. Andrew and Tom's like, I can't read that fast. What are you talking about, Mark? Actually, it'll be more than 5 seconds. But still, if we have a full understanding of it, just go bang, 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 looking down and reading it, then you'll get really high style marks because it'll be just instantly apparent that what you've done um, is easy to understand. Sometimes we get main functions that are really short, and all they are is function names. It's like this function name does this does this does this does this, and sometimes that's really good. So sometimes when you get that, it's really easy to understand because all you're doing is just reading the step by step. And it's like if I want to know more about what each of those steps are, then I go look further down into the code at that particular function and see what it does. So that's one way of doing things that's really nice. Um, we're not we're not pushing too hard for that, right? Like um, we're not pushing you to make everything super beautiful. Um, but if you are trying to 100% this assignment, so I'm only talking like two people here, but someone might be. That's a thing that you can do. But I would say, and this is a piece of advice Andrew was just pinging me about this. Readability is far more important than cleverness. Like you're trying to show off how much functionality you can squeeze into one line of code. It's a bit scary, but also it's really kind of not useful. It's like it's cool. You compressed your code into this small space, but it doesn't matter. It's going to get compiled anyway. It didn't matter how long your lines were and things like that. Like your computer's going to turn it all into instructions anyway. So the reason we write code in the actual C file is not necessarily for the computer. It's for us to be able to modify it again later and us to use it again later. So showing off that you're super smart and you can compress the entirety of CS Paint into a single line of C is just freaky as all hell. Like it's just going to be scary and we're not actually going to get that much out of it. Whereas if you can spread it out and say, okay, this is now fully understandable because of the way that I've structured it, that works really well. Okay, I think I should. Oh wait. Oh, there was another style question as a follow-up. Okay, the question was, yeah, the staff are laughing, and I'm a bit, yeah. So if the variable names are not descriptive, like ABC, is it fine to add comments to make up for the lack of description? Okay, so let's let's talk about comments in general. Comments are there when we couldn't do anything else, right? So let's look at comments nearly like this last resort of the coding, because a well enough written piece of code doesn't actually need comments. If it's well enough written, you can actually just read all of the words in the code itself and fully understand it. If the structure is really nice to see as well, you can fully understand it. So the comments should be there when you've tried everything. And there was no way to make it more easily understandable. So you get to this point where it's like, okay, now we need the comment because uh, everything else couldn't get us to that point. So I would say that instead of sort of making up for the bad variable naming by putting comments there, you would want to actually name the variables very well, especially because the comments can't help you that much. Because you can put a comment when you declare the variable, say this variable will be used for this. And then 300 lines later, when you use that variable and it's got a really confusing name, then you're just confused again. And it's like, what are you going to do? Are you going to put that comment in when every time you use that variable? So I got a variable A, which was like this start row. And every time I use it, I put a comment in saying A is the start row, A is the start row, A is the start row. And then I've added an extra 100 lines to my code, which are breaking up the structure of my code. And also then, because I have so many comments in my code then, because every time I use the variable, I'm explaining it. Um, then people are going to stop reading my comments. So someone's going to be going through and going, oh my God, so much comment spam. And then there's going to be a comment saying, hey, this bit's really important. This bit does this. And people aren't going to read it because there was too much comment spam. So yeah, I think I think you've got your answer that like I would definitely put variable names in that are good rather than trying to make up for it with comments. I think Andrew had something. Oh, um, yeah. So the other thing, however, about comments, and Andrew is reminding me that every time you make a function, it's really important to put a comment for each function. So we're getting deeper into functions now. We're going to start to use them quite regularly. You can have a function that has a very, very clear function name, and it's really easy in a way to understand what that function is going to do. But I think what's really nice is like when you've got your main, and then below that you've got other functions. If you tag each function with a comment just to say, okay, this is what this does explicitly so you don't have to read the code if you don't want to. So one of the things I like to put in the comments for a function is this is the information that it needs to run and this is what it gives back. So to talk about what the function is going to get given by another function or the main, whatever calls it, and also what it's going to do and what it gives back. And that should be enough. Um, Yeah. So Andrew was saying that the absolute perfect code has comments at the very top, the header comment, so saying who you are, saying the purpose of the entire thing, and comments for every function, and then that way that would normally be all you'll need to know to be able to use something. I mean, every now and then you're going to have some super, super complex code somewhere in there that you might want to explain. But even that, if you have your variable names right and you split it up into functions and each function has its own comment and a name that's really useful, then that's actually all that you need there. Okay, so I think that like we talked a little bit about style there, and we've got a bunch of other uh, questions. Okay, so this is good. Andrew's keeping the queue of questions up for me over there. So the question is, if I pass all of the auto tests, is my code perfect? So let's see, who was asking that one? No, that's the copy. I'm just scrolling through the chat. Right, so there were two questions here. So Georgia and Lionel Messi. I Is your name actual Lionel Messi? Isn't Lionel Messi like a real famous football player? I don't know. I thought it was, but I'm not sure. Maybe it is actually. Maybe you were named after a really famous football player. Sorry, I'll get back. Get back on topic. Okay, so two questions that were really similar here. Are there separate auto tests run for marking? The person saying yeah. Okay. The George is saying um, you didn't hard code anything, and that's good because you don't want to hard code to the auto tests. That's super dangerous. Um, and how extensive the available tests are versus the actual tests. Um, I'm going to actually, it doesn't really matter. I was going to go to the actual assignment spec and talk about it there, but it doesn't really matter what I'm showing on the screen there. Okay, so the auto tests are a certain section of things that we think you need to look at. And there could be a question which is, if I pass all of the auto tests, is my code perfect? The answer is no. And it will never be that case. I think I had in the slides last week or the week before when we were talking about testing that the tweet from the QA engineer that said we tested with positive values, we tested with negative values, we tested with the incorrect values types and things like that. And then the first customer came in to use the product and everything explodes and the place burns down. Um, that's the way it's always going to be. No matter how much time and effort we put into the auto tests and try to make sure the auto tests are really, really specific, there's always going to be a case that we didn't think of. Not only did we not think of them, sometimes we're actually going to leave them out on purpose because we're going to be saying to you, okay, we're going to check a few things, but if you wrote this code correctly, you should have been checking for everything. So really, really simple example of how we might do this. So let's go back to like stage one. Stage one says you draw a line in any one of four directions. Um, and then we might say, where's the invalid? There's if the draw line causes a line to be drawn outside the canvas in any direction. So if the draw line's outside the canvas, your program should ignore that draw line command and do nothing. So what we're saying is if there's any pixels that you're drawing that go outside the bounds of the canvas, then the entire line should not happen. Um, we might give you auto tests that test, say, three of the four sides of the canvas. So I can't remember because, like, I think Tom has written all the auto tests, but I'm pretty sure that we would have left one of those out just to see what's going on, right? So you could pass all of your tests, but you could have forgotten some fundamental principle, which is right here, saying like anything outside the canvas. So we want you to know that, and we want you to be able to say, I know the auto tests are testing a few of these things, but we want to make sure that our program is complete. And so the auto tests will give you a good idea where you're up to, but they won't give you as good an understanding as you have yourself of how good your program is. So you can say, I know the auto tests are testing some of these things, but I'm testing everything. I'm clear and I'm complete and stuff like that. So the marking tests are different from the auto tests, yes. Um, we will occasionally have some of them the same, but most of the time, at minimum, all of the values in the marking tests are completely different from any of the values that are in the auto tests. And you'll see this in labs and stuff like that, where some people will pass auto tests. Like I've seen the desperation sometimes that someone will pass an auto test by or pass a lab exercise by just reading the input, and there's an if statement for that line of input that gives you the correct line of output, and then an if statement for the other line that was in the auto tests, and they will print out the correct response. And there's no code running in that. It's just if I get this input, I give this output. And so they'll pass all the auto tests, and it's like, yay, hurrah! And it's like, okay, first automated actual test. And it doesn't work because there was no functionality behind the code. So that's probably not something that most people are going to do, but you can fall into the trap sometimes of passing all the auto tests, but not having thought about the theoretical completeness of your code of exactly how you wanted it to be. Couple of things here. So we've got a couple of other questions that Andrew passed along. Um, Ooh, actually, we had some other conversations. Okay, let me finish this conversation and we'll go back to a couple of other things that people were talking about. Um, is it safe to assume the number of inputs will always be correct? Vidvog Whitman is asking that. Yes. At the moment, we're not going to be testing you on whether the input is valid or not. We wanted to test you on your ability to use arrays and loop through the arrays and stuff like that, not your ability to do error checking on input. That's not what we were actually looking for in this assignment. So we're going to give you um, what I would call correctly formatted input all the time. It's not necessarily input that's going to result in a valid draw function, but it will always be the right number of inputs. So VidVoc, you can be like sure that's going to be the case. Um, okay, someone was also asking, your code is not passing. It's not passing the auto tests, but it is passing your own tests. So you've been running your manual tests on the code, and things are looking correct there. And I think the answer to that one is be really, really careful with the output format. Um, when we're working with humans, with our programs, we'll very often be understandable in our programs, even if a few characters are off here and there. But when we're working with something like auto test, where we're trying to make sure that this thing works for a computer to read, we end up with that same kind of situation when we're writing code where our syntax has to be perfect and exact. And if our syntax is going to be really perfect and exact, that means we can actually interface programs with each other. So it's an important skill to learn how to do, and that will often be the biggest problem. So the biggest problem we're going to get with not being able to pass auto tests is often something really simple. So you know how we were looking at doing testing by printing out all the data that's inside our while loops and things like that. We're looking at uh, printing out what the state of our program was, what some of our variables were, so that we can see it running as it's running. Some of those things might throw you off by accident. Sometimes it'll be really, really simple. Like there'll be a new line at the end of the output in the uh, in the reference versus what you have. So another thing that's really good for just checking exact correctness, and I've just scrolled here in the uh, in the assignment spec to the reference implementation. The reference implementation might be really good for that. So what you can do is run your manual tests on your own code and run your manual tests on our 1511 Canvas solution, I think it's called. And you can then see, like on two terminals right next to each other, the output. And the things to look for often in that kind of output is just an extra line of white space in one of the outputs, and you'll be like, oh, there's just a new line there missing that I've missed out or something like that. Andrew has something. Mm. Oh, right. Andrew's saying that the reference solution may also sometimes look right when the auto test is going to know that there's a difference. So um, the new line might not be something that you can see that easily in the reference solution, but sometimes it will. I mean, we had one person ask questions about this the other day, and it was really interesting, and we didn't realize that they were printing out every canvas. So each command was printing out its own canvas. And so everything they had in their code was correct. I looked at it after the lecture and I thought everything about their logic was correct, but I was looking in the wrong place. And it was just the fact that they'd printed out a canvas for every command rather than at the end, and where you only print out one. And then their code started working, I think, once they changed that. Okay, so I think the trick's always going to be little niggling things in output format. Um, the other thing that you could be having where it's working in your tests but not necessarily in the auto tests is when we compile your code in the auto tests, where we're super specific about this. If you have warnings about what's happening in your code, we don't allow you to submit code that still has warnings in it, because a warning means that something is going to break at some point when it runs. So the warning says that there's an open problem that hasn't been solved here. And if I was to just type in a certain kind of input to this, the program would crash. As opposed to if you don't have warnings, I mean, you can still crash without warnings, but the warning's really telling you that something's up. So sometimes when your stuff works, it's because with warnings it will run. Um, but if you can make sure that you've cleaned up everything so that there aren't warnings in the code, Often it means like you've accidentally used uninitialized variables, or you have the potential for running off the end of an array or something like that. You might get warnings for things that are a little bit like that. Um, you you can then have pretty significant issues. So we make sure that when we compile, we say you have warnings. So the auto test says no, I'm not even going to run the auto test because you got warnings here, so I don't think this code is safe to run. Also, it might not actually be safe to run my while loop forever. Although you can definitely make code that while loops forever that doesn't have doesn't have any warnings. We've done that. We've all done that. Um, okay, so other questions? Yeah, yeah, yeah. Especially like things like that where it's like all of my tests are working. I really feel like I'm doing well on this assignment and I fully understand it, but then none of the auto tests are running. A help session's really good for that. Because most of the time, that kind of thing will be just an issue with your assignment. So it's not even an issue with that's the same kind of issue that other people are having. It's really just going to be that there's one tiny issue, and it may not even be that big a deal. And a tutor can help you out with just narrowing down what that is. Because again, we're not assessing you on on whether it takes you like 30 hours to find one output bug to fix. What we really want to be assessing you on is, can you use while loops to loop through like a two-dimensional canvas or something like that? That's the kind of thing that we want to uh, that we want to see whether you can or can't do. So we really want the time spent on this assignment to be learnt about using arrays and using while loops and things, rather than um, having completed all of that and then having this horrible head scratcher that you have to work on for a few days just to get the output to match the auto tests, right? So we want the spirit of the assignment to be there for you uh, rather than you having to dig through things that weren't in the spirit of what we wanted you to work on. Okay, going through other things. Uh, Mary Taylor asked if this was going to be. Oh, Andrew's already answered that. Yeah, yeah. Don't worry. Everything that I'm saying now is going to be recorded. So if you have to go and do something else, because we do understand that we're recording, that we're doing this live stream at a time that's just outside of the class's normal timetable. I picked Monday for it because all of our tutes for this course are on Tuesday to Friday, and obviously we're not in a lecture right now. So we knew that no one was busy for this course at this point in time, but totally understand people are busy for other courses, and all this stuff is recorded later. And if you have a question that I don't get to, because there's a queue of questions at the moment, if you have a question that I don't get to, um, you can always go to help session, or you can always go to the course forum, and we will try to get to all of those. I guess it's kind of it's nice to have some of these questions answered right here and now in the live stream because you can get your answer straight away. Okay, let's go back to the question queue that we have. Ah, this is Josh's question. Oh, so Lionel Messi was saying yes, your idol. So you weren't necessarily named after Lionel Messi, but you enjoy his football. I think I've only seen a couple of games ever that he was in because I'm one of those people that just sort of watches when there's a World Cup on, and then I go back to not watching football at other times. Or I'll call it soccer, and then people get really angry. Yeah. Okay. Um, Josh was asking, I think that's the next one in the queue. What's a general template look for comments above function prototypes versus function definitions? We very rarely will put individual comments for functions at the prototypes because the prototypes are there so that the main function can use them. But we will often do kind of chapter headings for those. So what we might do is say, here's 8 functions. These 8 functions are to do with this. They're in support of this thing. So when the prototypes are there and there's a stack of them together, you can go, okay, these ones are for this kind of thing. And then these are helper functions for this kind of thing. And then when we go down to the actual definitions of the function, so all of code of the function, that's where the thing that I would say for those is nearly, not exactly, because it depends on the function. These are the inputs and these are the outputs. So that's the thing that I usually say is this function takes these things and it does this kinds of processing to give this. It's not always going to be inputs and outputs though, because we can have void functions. So we can have functions with no input and functions with no output. We can actually have functions that have no input and no output. All they have is side effects, and so they need to be explained. So I could have a function that says, this function is going to print this amount of information to the terminal. And so I still need a comment for that function, even though there's no inputs and outputs to explain. But usually my recipe for comments for a function, like in the definition of the function itself, is this is what information we give it, this is what it does, and this is the information it gives us back. And you could replace those informations with these are the side effects of when this function runs. Because sometimes it's like, I'm going to, and now we've talked about this, right? So we can do this. I'm going to give this function pointers to some of the data that's in my code. And so I'd expect the comment there to say, this function's going to take those variables and make these changes to them. So we know what the side effects is without having to actually look through all the code and see what they are. All right. What other questions do we have? Um, Bubble tea for everyone. Did you get a bubble tea yourself, Lee Chen? That'd be really funny. It'd be like, all right, I'm gonna go get bubble tea while the stream's on. I can watch this again later. Yeah, that's the ultimate decadence. Do Uber Eats to deliver bubble tea. Does that actually that's actually a thing, isn't it? We should totally do that because my bubble tea's run out. So that's it. Stream's over. I can't do it anymore. No more bubble tea. There's an algorithm for bubble tea, by the way, that involves trying to make sure that the tea runs out exactly the same time as the bubbles, and it's all about lifting the straw off the bottom. There you go. Useful, useful tips for life. Um, okay. So we've got some questions still here. Um, have we answered this one already? Run a test case, wrong result with it, but having the same result run around Canvas solution. Why am I failing the test with that? I think I've kind of answered this already. Most likely, if it looks the same in the Canvas solution as in yours, it's going to be something really, really tiny. It's going to be a new line at the end or in between or something like that. And this is the kind of thing where I would suggest not a bad idea to get some help at this point because sometimes it's like I just can't see it, right? I can't see what the difference is, and it might just be a new line somewhere in the output, but not sure. Not sure. It'll depend, and that's the kind of thing where we will help you with that because that's not important you know like what is important is whether you have an understanding about the concepts that we've been teaching, like can you loop through things, can you handle arrays, can you read and write to arrays, and can you deal with two-dimensional arrays. Those are the kinds of things we're saying, okay, these are the things we want to give you marks for. We want to give you marks for understanding of the course, and we do want some marks in your capability to run testing and debugging and make sure things are going correctly and things, but mostly that is like fixing your code, not tailoring your output to exactly talk to this robot. So we can give you a bit of help with that kind of thing. That was Hasten Shim's question there. Okay, if my while statement or prototype function comment is too long, how would I shorten it, especially if everything is needed in the function? So this is John Aspite here asking this. Uh, if you're asking about shortening the comment itself, are you asking about shortening the comment or shortening the actual code structure of the while loop or not? I'm wondering about that because it could be like if we're talking about shortening comments, there's nothing wrong with a comment having to go down to another line if it has to. So if you have a two-line comment or a three-line comment for something, if it really, really needs that full explanation, then yeah, you can do that if you want to. So you can have comments that go over a line. But if you're asking about the actual call it the actual kind of question part of the while loop, so the thing that's in the brackets, it can be a good idea to split that over multiple lines. I actually think it makes things a lot more readable. Let me just should actually, I should have had this open from the beginning, but I'm just going to make a file. I'm just calling it livestream1. And I will just do our standard setup. Can everyone see this okay? I assume that everyone can see this okay. I don't have it all showing up on my screen there, but I'm sure it's going to be okay. Yep. So, uh, actual code structure, John is saying, yeah, okay. This is what I thought it might be because I figured you could probably put comments on multiple lines yourself if you wanted to. Okay, so let's say I've got int x equals 5. I'm just making up stuff here, so just for example. And I have a while loop that I want to go that x is less than, and I'm going to have like a maximum or something. Define max loop 100 or something like that. So x is less than 100 and y is greater than 25 and x is less than y, and I'm just making stuff up here because I'm just trying to pad this out so it's the same problem that you have. And x mod 24 is equal to 0. I don't think this is ever going to run because there's so many conditions. There's probably conflicting conditions here. But I just want to show you like what can happen if we have too many things to ask. And I assume this is probably happening in your assignment where you're saying there's just all these things I want to check. Like I only want to loop if it's like this, and if it goes off the end, I want to stop looping all this kind of stuff. What we can do with this part here if we want to, because at the moment this is nearly an unreadable mess, right? So we've got one test, another test, another test, another test, and these are separated by these ands. So if we want to, we can actually do this a little bit like the same way that we would do the code inside the while loop. So this is, I don't know, x plus plus y equals x, etc. We can do that kind of thing, and we can actually do it with these tests here if we want to. So if we want to, we could actually outline these vertically. So what I might do is start off by taking my brackets here and doing the while loop itself as if these smaller brackets are containing a piece of code. So I'm containing this piece of code here. And then remember what Andrew was saying earlier. One piece of code per line. We do one thing per line. If we want to, we can do our if statement checks one per line as well. So I could do something along these lines. So yes, this is going to take up more vertical space, but you can kind of see immediately that that my code here is a lot more readable in terms of in terms of what I'm going to see if I'm looping here. So this is one way of doing it. It can get a bit messy, and often if I'm checking this many things in a while loop, then could be um, there could be a structural issue here in me having to test this many things at once. So maybe there's something else I ought to be doing. I'm only saying maybe there because I don't know. Chances are there is a situation where you actually need to check all of this stuff and go, these are all of the possible ways this while loop could stop. And so we are going to need to check all of them. Some of them may be redundant, though. You never know. Uh, Another suggestion here is that maybe this can go into a function, and it can go into a function where some of these things don't need to be checked as much. But always hard to say. Uh, every individual um, every individual piece of code is going to have its own little issues about what it needs to do. But if you do have multiple questions in a while loop that you want to be readable, this is one way of doing it. So what we've done is said, okay, this bracketing here looks similar to the standards we have for other bracketing, where everything that's inside something gets tabbed in. So that's one way of doing it. That was whose question was that? That was John's question. Yeah. So hopefully that gives you a decent enough answer of what you can do if the while loop's too long and you want to make all of the questions in the while loop, make them all visible so that your stopping case is really clear. I mean, having said that, even with this, the stopping case is not very clear, because what if I did something like this? There's an and there and an or there and an and there, and I already don't know what's going on, right? So this is one of those cases where even if this is 100% correct code, it's doing exactly what you want. This is really confusing. Like I can't just look at this and go, I understand how this while loop stops. So got to be careful. I also use really bad variable names here as well, so it's hard to say what's happening there. There may be another way around that, maybe, but your own code's your own code, so it's always hard to say. Okay, so other questions. Um, so we had Lee Chen was asking, what about if the array is not initialized at the beginning because it's waiting for user inputs? Um, is it okay to have an array that we don't initialize, but then we fill with information later? Oh, Andrew has something he wants to say here. Ah, yes. Okay. So this was about oh, right, right. Your question was about warnings. If you are getting a warning, it means you're reading from it. So it means there's something in your code that's reading from it before you've written to it, or you're not writing to all of it. So this definitely happens with something like user inputs that are strings, for example. Then we're going to write. So we've got like this big array. We've got like I don't know 100 length array, and we write to like 6 letters in it. The rest of it's going to be uninitialized, and you have to be really careful with that rest of it. So if you're not sure if you're going to fill up the entire array, then initialize it. Then do something with it. Even if it's just all zeros, at least there's data there and then you can check for it. Or even better, initialize it to something that you know is going to trigger something else in your program to stop it running or to say, this is where I know I've caused an issue. Yeah. So if you're getting a warning about an uninitialized array, it means that there's something in your code that is actually reading from that array before you've put that input into it, or you're not putting the input into the entire array and there's some gaps. Usually after whatever you've written, there's some gaps that are uninitialized, and then you're looping through the array later or something like that. So I would look for subtleties in that, and that's a good warning to have because that's a really, really dangerous thing. If we have uninitialized data in our arrays, it's super super open what it does. So some compilers are going to be really friendly to you and have the uninitialized data and just make it all zeros. And then you can be really thankful if that happens. Other compilers are going to be like, no, we're not going to do extra work. We were compiling this thing so it ran as blisteringly fast as it could. So what we do is we assign you a piece of memory, and whatever was in memory before you did anything just stays there, and that's the values that are in your array. And then when you start reading from them, you get all these random garbage data. So um, so you got to be really, really careful with uninitialized because there is nothing to say what's going to happen if you read an uninitialized variable because we don't know what the value is going to be. There's this keyword of like which one is it? It's unintended behavior. No, it's not unintended. Sorry, undefined behavior. And undefined behavior is one of the scariest things in programming because it's just like we don't know what the code is going to do, and it won't do the same thing every time. So depending on where in memory this program was when it compiled, it's just going to act differently. And the toughest thing is sometimes it's going to look like it worked. So sometimes it looks like it works and it runs, and then the next time you run it with exactly the same input, it fails. And so that's the scariest thing that happens when we don't initialize our, uh, our variables before we use them. So just watch it. If you're getting a warning, chances are there's somewhere. So look at the order and see whether there's somewhere that's reading from it before it's written, or it's not writing to the entire array, so it's not initializing it fully before something else loops through it. Okay, okay. So we've just hit 5 p.m. And just the same way that I do this in lectures, I don't really like to try to talk for too long without having a break. So we're gonna have a really quick break now. I don't know, 4 or 5 minutes. Same kind of thing as in a lecture. We'll take a little break, and we have written down all the questions, so we're not going to leave any of the questions behind, and we'll go through other things in the second half. Okay, so I'm just going to go into a be right back and mute the mic for a couple of minutes, and we'll be back in a moment. All right, we're back. Oh, sorry. I just started up again just as Andrew was about to tell me something, so I've cut him off. We'll talk later. Okay, so we're back. And as is the smartest thing to do, I was talking to the others through the whole break instead of actually resting my voice in between the 2 hours. But all good. So we still have a few questions that we're looking at. So we were looking at the warnings about the array, not being initialized and saying, okay, those are potentially genuine warnings. So look at the order in which you're doing things. So the next question was from Anon L. I assume that's anonymous, but with an initial L. Still stuck on stage one. So advice for being stuck on stage one. Okay, so let's go back to the spec. So first thing I would do, if you're stuck on stage one, is I would have a look at the reference. Well, not the reference. Let me see if I've actually got it here. CS Paint. This is super risky. I could be opening the solution. I'm pretty sure I'm not. The admins are just laughing. I don't think it's like one of those panic laughs. It's just like, what's he gonna do? This is unlikely to be the solution because it says your name here, assignment release. Oh, the solution says that too, doesn't it? All right, good, good. No. Okay, okay. I'm not giving away the solution. Okay. First thing I would do is I would grab this piece of code and I would say, what do I need to do? Um, and I would have a look at the spec as well, but I wouldn't look at anything in the spec past stage one. So if I was stuck and not fully understanding things, what I would think about is what exactly is this program going to need me to do, and how do I put this into the context of things I've learned. So you've done things like lab exercises before, and you've done things like weekly tests and things. So you've gotten to the point where you can kind of get some small instructions for a piece of code and then get that thing going. And even if it takes you a while, you could still get it going, right? So what I would suggest is getting this first one and simplifying it until you can do it. So what I would think about is saying, I'm going to take in this command. So let's just, for starters, assume there's only one command. So I think that you can get plenty of marks working on a single command without having to do one command and then another command. Also, doing all the code that gets you a single command working is not going to stop you from then being able to loop that to do it multiple times. So what I would do is that I would read this stuff in and I would say, let's break this down into pieces. So it's exactly so you know, what I've been trying to teach you in lectures is like how we break this thing down into pieces. The first thing I would do is say, I'm going to read in this command, and all I'm going to do is print out a single printf that says, this command is a draw line command, and it is asking me to start at this position, and it's asking me to go this far in this direction. So that's like really, really easy, right? Because what we're going to do is we're going to like maybe scanf for multiple integers. And then we're going to say, if the first one is a 1, then I'm going to say it's a draw line. If the first one is a 2, then it's going to be a square drawing. Having said that, I think they have a different number of inputs. Tom, they have the same number of inputs. Okay, so you could actually just go 2, 3, 4, 5. I'm going to read 5 numbers in. And then based on if statements for those 5 numbers, I'm going to say that I'm going to do certain things. And that way, what you've done so far is you've gone, okay, I can read the input and I can understand what the input's asking me to do. And then what I can do is, okay, given that, I have more stuff that I'm going to do. So what I could do is say, draw a line starting at this pixel. And what I do is I don't bother about the whole line. I just go, I can find that pixel in the canvas and I can change its color. So what you do is you go, all right, you have this thing that prints out, I was told to draw a line starting here to go this far in this direction. It's nearly like you just want to like write out this. Because if you write out this line of text here, you can say that I took this bunch of numbers in and I understood what it was asking me to do. Um, Having said that, you're not necessarily going to submit something with all these print statements in it, but it's really good for you to see whether your code's working or not. Because the first few times you run this, it's going to be like, maybe it can't identify that it's a draw line, or it gets some of this information incorrect. And then you go, okay, I need to clean up how I'm reading these numbers into variables or whatever, and then what I'm doing with them. Once you've got that, you want to look at making changes to the canvas. So once you know what the command is, you can say, I was supposed to draw a line, and it was supposed to start at this position. And then what you do is you just change the number in the canvas for the starting position. And what you can do is you can actually do that against the reference implementation and go, the one that I changed was in the same position as one end of that line. And you go, cool, okay, I'm pretty close to correct there because I've got something starting in that position. And then you can think about, if I want to draw along a certain distance, for a certain amount, for like, say this one, I'm drawing 8 pixels in the direction 180. I need to first think about, okay, which direction is 180? Zero's up. Hang on, where is it? There's the, here. This is the diagram we have, what the angles are. Stage 1, you don't even need to worry about any of the diagonals. You're only going 0, 90, 180, 270. So you're saying, is it one of these? If it's one of these, this is the direction I'm going in. The next thing that you want to do then is to start to try to draw that line. And that's where things get a little bit complex, is you want to be looking at your canvas and saying, this is where I started. And if I'm going upwards, what changes to my coordinates do I need to do to go upwards from that position? So remember the, what did I call it? The tourist that we were working on, where I had the square grid and I had my 8462 numpad directions, and each time I picked one of those, I was going to move on the canvas. So I was either going to move up, down, left, or right. You have the same thing where you're moving up, down, left, or right, and depending on moving up, down, left, or right, you're going to change the coordinates of the next pixel that you're looking at. And if you're going to change the coordinates of the next pixel that you're looking at, you can say, okay, I changed the color of this pixel, and then I take one step in the direction I'm supposed to go in. So this one's 180, so 0's up. From your angle, 90 is to the left, 180 is down. So if I'm going to go downwards, then I need to decide which coordinates to change to take one step downwards. And that's going to be something to do with uh, changing which row I'm on, most likely. I'm not going to tell you everything, but it's going to be something like that. In fact, if you look at my tourist code, it actually has the rows and columns, and it shows you how to take one step downwards. And so you take one step downwards, and then you change the color of that pixel. You take another step downwards, change the color of that pixel, until you've taken the right number of steps. So you can kind of guess there that what I'm describing is a while loop. And a while loop is going to go for a certain number of times, and then you're going to change each pixel as you go past it. And I reckon that's the starting point, because then once you've done that, you have correctly processed the input numbers. You have found a way to decide where on your canvas you start and how to access all of the pixels on the canvas that you were supposed to change. And then you've changed the values in those pixels. And that's just, if you want to know about changing the values of the pixels, that tourist demo that I did in the lecture is a pretty good one to go back and watch, because that thing actually walks around step by step and it changes the values as it walks past them. So there's going to be something in there that you can use. I mean, it's not going to be exact, because obviously I'm not going to exactly do the assignment solution in a lecture, but there's a lot in there that I did on purpose because it's a lot of what's in stage 1 here. And so that's my advice for Anon, that I think that's the best way to get started. Break it down into parts and do them as easy as you can, and then slowly build up the complexity as you're going from there. When we get on to the second part of stage 1, which is the square drawing, here, if I want to fill a square, then I'll probably be doing a double loop, right? So when I was drawing the grid of stars, that was like really early, before even using arrays. I was just going across, across, and across, and across. You're probably going to fill a square using the same kind of structure, but instead of just printf stars, you would be like, where am I in the canvas right now? So it'll be um, from some coordinates to other coordinates. I'm going to fill those in with colors. A skill that's really handy to learn for getting started in this assignment is looping from some part of an array to another part of the array. So a lot of the loops that we've shown in the lectures and things have been loop from 0 to size minus 1, right? So that's the entire array. But what if I want to loop from halfway along to like 2/3 of the way along? Or, for example, what if I want to loop from the position 10, 3 um, 8 times? So how can I construct a while loop that goes exactly a certain number of times from a certain position in a certain direction? And so, you know how we're just doing I plus plus at the end of all of our while loops? Maybe I is not the only thing we're changing. Maybe we're changing row. So maybe I'm going row plus plus each time, or maybe I'm going row minus minus each time, you know? So we need to think about the other ways that we can loop through things. Uh, Hopefully that's enough um, to give you some information. Oh, there's other people asking about stage one as well. So David was asking about stage one. No issues drawing a right downwards due to it being either row plus plus or column plus plus. However, I do column minus minus or row minus minus and I get infinite loops. My suggestion to you, David, if we're getting infinite loops, is look at how your loops are stopping. So one thing that we were always doing is we were like, when we were looping through a normal loop and we go to size minus 1. So I say the loop must be less than size. If you do a minus minus and the loop's less than size, it's going to keep going, right? Because it's just going to keep going down into negative numbers and things. So we need to look at how we're going to stop those loops. I don't know if this is definitely the issue that you're having, but if we're doing a minus minus, then our stopping case might be on the other end of the number line from where we were thinking. So like if we think about like we're going this way, we have our upper limit of where we want our loop to stop. But if we're going the opposite direction, we've got a lower limit of where the loop needs to stop, and that should be our while loop condition. So we can't take the same while loop condition and just flip the direction that we're going in our incrementation. So we can't just take a plus plus and turn it to a minus minus without also changing the stopping case. See if that helps. I don't know because I don't know exactly what's going on with your code, but it could well be the trick that gets you through that. Okay, let's go back to our questions. So I think that's enough. Hopefully that's enough for everyone who is looking at stage one. These are some of the things that I say are the sort of the best ways to get started. And I think that advice is going to be useful for everyone because anytime you have like a piece of code to work on, a big chunk of problem to solve, one of the most important things is to break it down into manageable things and to not try to solve it all at once. So how I was saying at the beginning, don't even draw lines. Just read in the input and do a printf that says this is what I think this input should do. And then you can even test that. So you get your program and you run it on some input and you say, I think this should do this. And then you run your reference solution. It's like, oh, it did exactly what I thought it should. And so that way you go, okay, I know that bit's working. Once I know that bit's working, then I can move on to the next bit and see what's happening there. So little things like that, I think are some of the best ways to take something like this. Because when you think about this, this is a massive piece of work, right? There's all these multiple stages. Every stage has multiple things in it. So every stage has at least two different tasks in it. And each one of these tasks is like, I would say, an entire lab exercise on its own. So if you do that and you treat it like you're going to ignore everything except for this line drawing thing, then if I just want to do the line drawing thing, I still need to break this down into its parts before I can fully work it. Um, the nice thing is once you've got this, it's actually not as hard to then extrapolate what you've done in that to the next ones. But in general, same advice I'm always going to give you for anything that looks a little bit daunting or has confusing bits in it. Break it down into smaller parts. Solve those parts, even if that's not what's going to get you the marks in the assignment. It's not even going to match up with the auto tests, but it's going to give you the knowledge that part of what you've written is correct. Then you finish that bit and then you can move on to the next bit. You're not always going to be able to move on entirely. Sometimes you go back and forth and stuff. So we're never going to like just sort of abandon something after it's done. But at least we have some parts of it that we go, okay, we know this bit works, which means we're going to attach something to it. And when we attach something to it, we'll know that anything we've written afterwards, if something goes wrong, is likely to be the issue, not the thing we did first. As opposed to trying to do the whole lot at once, you've got like twice as much code where you don't know whether any of it works. So breaking things down into parts and getting them going in a small way is probably better than trying to do a massive amount all at once. Okay, okay. So, tips for debugging when the output is wrong but there are no errors. Okay, so this is where, and we've talked about this in lectures. This is where what we're likely to be getting here is a logical error, and the logical error is the code is compiling, no warnings, no errors, it's running, but the output is not what you expect, not what you intended. Um, when we're in that kind of situation, I think the key to dealing with that kind of situation is what information can you get from your program? So if the only information you're getting from your output is the final canvas, and you're going, final canvas is wrong, and there's like 8 commands, there's like 8 lines of commands, and the final output is wrong, it's going to be quite hard at that point to figure out which part of your code is incorrect. And so my advice for this is always let's try to get as much information as we can out of our code. So let's say let's do a print output of each of the things that we're thinking of doing at any particular point in time. So what I could say is, so like that code that I was saying before that has this that says, okay, this is what the command tells me I'm supposed to do. If you run that, if you don't do anything with your canvas, what you do is you just say, these are the inputs that I got. Um, and so these are the strings of numbers that I read, and these are the commands that I think it should do. So you just say, it should draw a line from here to here. Um, it should draw a square starting in this position, or even just go, these are the 4 corners of the square. So you show that you can actually decide exactly where it is. Then you copy from this location into this location. And then you can look at it and you can say, okay, if I was a human and I was following those instructions, what would come out of that? And you can see if your instructions are correct. Once you're sure your instructions are correct, then you can have that list at the top, and then you could execute those commands one at a time. So you could print the canvas in between each execution of an individual. Sorry, trying to speak too fast. I'm tripping over my own words. Each individual command prints a canvas, and then you can say, is that was that the correct canvas for that command? And then the next one, was that the correct canvas for that command? That kind of thing. And then you'll be able to find out which one's not working, because one of them will stand out. It'll be like, that's not it. Maybe it's something else. And then you'll be able to narrow down which section of code is where your logical error is. Because that's one of the things about errors in not in whether your C was the correct language C, but errors in terms of whether you've got the right idea about what you needed to do. It's very much harder to find them because they don't just give you a line number. They give you a consequence way down the line. So the trick for us is then to just find out consequences at multiple points in our code, find out where each of those is the issue. That's my advice for debugging that kind of thing. Um, Another funny piece of advice that I've often heard and given about debugging is if you've been there and you've been debugging this thing for, let's say, I don't know, you've been there for like 4 hours with this one issue or something, like that's actually a long time, and you're not getting any information, you don't understand it or anything like that, get yourself out of that headspace. So you need to go for a walk. One of the best things to try to do is to get some blood flowing to your brain. You could go for a jog. Um, you could go, I don't know, walk your dog. I don't know if you have a dog. I don't have a dog either. I have a dream of having a lecture dog that just comes with me to the lectures and just sort of sits there while I teach and then barks when I make particular statements. I think that would be like that would be top notch right there. But I sorry, I was just like off dreaming about my lecture dog and forgetting what I was actually explaining. getting a break is important. I've seen a lot of people with what we would think of as just like bugs that we don't get. Like really, really serious bugs are just breaking the entire production line for like a team of like 10 people or something like that. And like we send them home, they go to sleep, and they come back the next day and they've got the answer. Because sometimes it's your subconscious needs to just sort of turn this thing over, and you need to get your head away from the kind of constant push to try to fix it. Because a relaxed brain is going to think about its options much more easily than a really kind of like not letting yourself stop focused kind of brain. So you can follow the process, right? Follow the formal process that I'm telling you, but sometimes there's a sort of the leap in thinking needs you to step away for a bit, and especially get some blood flowing. Your brain uses blood, uses energy like anything else. Um, I could also ask you, when was the last time you ate something? And if that's also before that 4 hours worth of effort that you put in, your brain's probably so low on blood sugar that it's not going to help you now anyway. Any code you write by that point is just going to be really bad code. So little things like that can really help with debugging. I feel like I could teach an entire kind of thing session just on like the psychology and the headspace around debugging. Um, I have stuff written down. Maybe one day I'll write that up in a format that's really useful and give it to everyone. But that day is not today, sadly. Okay, so that's the advice I want to give about debugging. That's as much as I can give you right now. Um, Jordan is asking, hey Mark, could you do a quick example of how to copy a single pixel? Or is that too much to give away? I tried modifying the display canvas function by making it scan each dot instead of print, but it doesn't seem to be working. Um, I don't think I can. If I write code that copies one pixel to another pixel, I think that code is going to have stuff in it that will basically solve stage one of the assignment, because all of the infrastructure building up to that is going to have lots of things. But if I do something like, okay, let's just do a function that is not in the canvas, but it takes a two-dimensional array and a source pixel and a target pixel, and it copies the value from the source of the target pixel. I could do that. That's outside of the assignment environment, but it's still something that could work. So I'm thinking, I think this is a void function. I don't know. This is the kind of thing where I'm not entirely sure what this function should do. What I will often do is put a comment first and say, okay, I'm not going to say this function. I'm going to say copy pixel takes um, the dimensions, not dimensions, coordinates of one pixel. I'm going to say of a source pixel and the coordinates of a target pixel. It writes the value from the source pixel to the target, all in a two-dimensional array. Okay, so I've got some information here. It takes coordinates of source pixel and the coordinates of a target pixel in a two-dimensional array. So the nice thing about this, sorry, let me shift this over so that my face isn't getting in the way of the code. I've got it in lecture mode, not live stream mode. The lecture mode doesn't have my face in the corner because you've got my face in person. Paul Squawks is saying that you have a dog called Bud to bring into the lectures. Uh oh, Paul, debugging is not just the bane of your existence. Debugging is the bane of everyone's existence. I wasn't joking when I said that we're going to spend 85% of our time debugging. Like, I think you'll spend a lot of time debugging at the moment when you're not as clear on how to create code. But imagine what you can get to when you get to a level where you are clear on creating code and you can create a whole lot of it really fast, because that's the situation a lot of us get into, is we can create code really fast, but that doesn't actually make the code more accurate and doesn't make the code necessarily solve our problems perfectly. And so you'll get to this situation. A lot of your tutors will be in this position where they're able to create code really quickly, which means all they do is create a massive, like, in one day they can create 2 weeks worth of debugging for themselves. I did that once. I made the mistake of working on a project. I had a good run, right? I started at midnight and I went till 6 a.m. and I just got all this stuff complete. And all I did was consign myself to the next 2 months of debugging what my half asleep code was. And I really, at some point in those 2 months, should have thrown the whole thing away and coded it, say, from midday to 5 p.m. Something like, where a human brain actually focuses and thinks. But unfortunately, yeah, so yeah, debugging is not going to be a thing that we're ever going to be able to get rid of, but we will get better at it. So it is just a matter of practice, and we'll get there. Okay, so talking about this copy pixel thing. So I said there's a couple of things that I'm going to need. So a couple of integers. Um, so I'm going to call it source row, source pixel, source pixel, source column. Um, this is going to get long, so I'm going to push this to another line. So I'm going to do that same kind of thing that we were talking about before. So I've tabbed this in here. Um, and I'm going to do these in ways that I think are intuitive to me. So instead of just doing one per line, I'm actually going to do um, the conceptual, like the source row and column and the target row and column are like this. And then we had a two-dimensional integer array. What I might do for this actually is allow myself a little bit of ease of use here, where I'm going to define uh, n rows. I can't remember exactly what they are in the assignment, so I'm just going to do a really simple one by 10 by 10. So the maximum number of rows and columns is 10, 10, which means I can say this has number of rows and number of columns. Okay, so this is the input that I said I was going to have. We've got the coordinates of the source pixel, coordinates of the target pixel, and we're going to write the value from the source pixel to the target pixel, all in this two-dimensional array. So the actual code in my function is here. So I am writing to the target location. So somewhere in Canvas, to access a single element in this, I'm going to give it both a row and a column. So I know that the rows is the first one, columns is the second one. So the target row here, target column here. So this is the thing I'm trying to write to. So I'm writing to the target from the source. So this is a single integer because I've addressed both the row and column to get a single integer in the canvas. So I want to get that from the source. And the source is also in the canvas, but it's in a different location in the canvas. So it's in the source row and the source column. And at this point, you're like waiting for me to write more code, right? But that's it. This function is going to take whatever value was at the coordinate location of the source row and column, and it's going to write that value into another part of the canvas where the target row and column is. So this is all it needs to do. If I'm going to do a single pixel, then this is my copy paste for the single pixel from one location in the canvas to another location in the canvas. All I'm doing is I'm reading a value from the canvas and I'm assigning it to another value. Well, not necessarily a value, another element of the array. So I'm reading the value from this element of the array and I'm assigning that with the equals to this element of the array. I will point out that once we need to do this with multiple pixels, it does get more complex. And if you get to stage 4, it gets exceedingly more complex because this simple thing of copying one to the other doesn't always work if they overlap each other. But, if we're looking at this level, this is all we need to do here. Um, so, so I think this was for you, Jordan, right? And you're saying, so I would need to make a function similar to display canvas that scans each pixel instead of printing each pixel. You could do something like that, definitely. I wouldn't necessarily scan every pixel um, in the entire canvas, because if you're doing a copy paste, you know that you're copying from a specific square, right? So you only need to look at the pixels in that square and then write the pixels from that square to the pixel somewhere else. And so yeah, you could totally take this copy pixel and say, I'm going to run copy pixel, but I need to be able to give it the source and target information, which means you've got two squares. Let me go back to the picture. Copy paste. You'd be wanting to run some loop over these two squares that loops through them. Or actually, it doesn't even need to loop through both. You could just loop through one. Oh, no, you kind of maybe need to loop through both. Yeah, loop through both. And wait, from your perspective, it's like this. I always have to flip things around in my head. So from your perspective, it's like this. You're looping through, and then each thing you see as you're looping past, you're reading from one and writing to the other. I'm looking at the screen up there to make sure my fingers are actually on screen. They're not entirely. There we get oh no, I need to get further back. Yeah. So you're looping like this, and then you're reading from this point, writing to this point. Then you're reading from this point, writing to this point, and you're going along and doing that, and then you'll be able to do your copy paste. There you go. This is me stuffing around with the camera for a while. Okay. So we've only got 20 minutes left, so there's going to be a couple more questions that I want to go through before we go too far into this. So what do we have? Um, so we talked about William's question about debugging. Anon was asking also about incorporating functions. I think at the point where you're talking about you can't work out how to get things started, if you can't work out how to get things started, you don't have to necessarily throw functions in. Like, throwing functions in will get people more marks, but getting the functionality of doing the basics of drawing the lines and stuff like that is going to get you more marks than adding functions into your project. I think once you've gotten your pass mark by getting all of stage 1 done and you're trying to get a credit, then you can start moving things into functions and you start to get higher marks than that. But I would say one problem at a time. You know, I would say if you're asking me about I'm not sure how to get started with part 1, I would say ignore functions entirely, treat it like a lab exercise, and just try to get that functionality going, because those are the kinds of things that we're going for. And if you want to learn how to use functions, get practice with functions, you'll get that in the second assignment. And you'll get that in the labs coming up as well. So this week, actually, the labs have functions going in them, and we're building up the functions bit by bit. So it's in the tutorial as well. I think Oh, actually, you never know. After your lab this week, you might be like, "Ooh, I now know how to throw a function in." So, so it could be something that you could do later. Um, but it's not entirely necessary to pass this assignment to need functions. Uh, Having said that, if anyone's pushing to a credit and beyond, I will expect some use of functions, because I don't want your code to just be like all this massive one thing in the main file once you're building up that much code. Okay, so um, how are we assessed on code style? Melantha Wang is asking that question. Um, you have code. Oops, sorry, just checking something. You have code that looks like it's repeated, but they're slightly different, so you can't find another way other than copy, paste, and modify. So this depends on what you're modifying. Um, if you're modifying let's say just for example, we're drawing a line that can go in one of four directions, and you're thinking there's no way to do this because the loops are going in different directions and things like that. So what I'm trying to do is do this, but I've got four different while loops. So there's 4 different while loops and they're nearly exactly the same. Each one's drawing a line in a different direction. There are some ways to make this work nicely. So for example, if I have one line that goes up and one line that goes down, both of them are potentially going to cover the same sort of set of pixels. So they're all going to have the same column, but their rows are going to change. So either the row is going to change positive or negative. What you could actually do for a function like that is you could pass a number into a function, which is the direction, and either it's a +1 or -1. And then that way, suddenly you've got one function that does 2 different directions of the line drawing. So I could take that from 4 different while loops for drawing lines into 2 different while loops for drawing lines, one which draws vertical lines and one which draws horizontal lines. That's just one example of something that we could do. Again, this is something that it's going to come with experience, right? So I came up with that because like I've done enough programming that I can fiddle with the numbers like that, and I can be like, if I have a function and I input a number into it, is it going to work just as easily if it's negative or if it's positive? And it's like, maybe it will. Maybe there's a way I can do this. Another way that we could do this if we wanted to be super, super tricky about it is what if I take any line in any direction and all I do is I have a function that has this is where the line starts and finishes. And then in that function, it has a way of telling the difference between them. So whether we're going in a positive, negative, in which direction, and it says that's what the incrementation is inside the loop. And then I can have one function that draws all 4 lines. Those are just possibilities. Um, Obviously, I don't want to give everything away, but those are ways where I would, because I think that there's a way, and I haven't done it recently because I haven't done this assignment recently. I haven't actually done the other side of the assignment, actually implementing the stuff that you're going to do. Um, but I'm pretty sure that there's a way to do this where I write one while loop and I pass in the right information. I can draw lines in any of the 4 directions with just one while loop. Um, all it's going to take is some practice with dealing with while loops that go in different directions, or while loops where you can change the direction it goes in um, based on what inputs you put in. So it's not everything is a plus plus or a plus minus. Maybe it's a plus a variable, and that variable is a positive or a negative, and that can change the direction it goes in without having to rewrite the while loop and changing things. So little tricks like that. And don't worry if this is all like, whoa, what the hell's going on there? These are the kinds of things we learn over time, and then we can make our code more compact and easier to use like that. And then if it gets really complicated like that, obviously we push it away into a function, and and the function's just called draw line or something. And then when I'm reading my code, it's like, oh yeah, that thing's going to draw the line, and I did that earlier, and I know that that works. So little things like that. Okay. Oh, we've still got 15 minutes left, so I think I should be able to still answer everything. So that was asking about assessing code style and the idea of the copy paste. The copy paste is always scary because you kind of know when you're copy pasting, it's like, oh, this is repeating, you know? Um, and yeah, it's always going to be a matter of the thinking cap. So we put our thinking cap on and we say, what other things could we do to to make this to make this work in kind of a smarter way? And it'll take some time and some practice, but before I think that's going to fully click, but it'll get there eventually. Okay, there was a question of how do we scan multiple lines and do these lines in the same time, like using line to create a box? Um, so I think what you're asking there is about if we're filling a square, for example, how we go along those lines and fill the colors in the square. Um, One of the structures that I think you want to look at for that is going to be, I think one of the previous lectures where we were drawing boxes. So we were just taking the dimensions and we were doing a double while loop to draw a square of asterisks. That's decent, but not quite as good as if we have stuff that's going to go through a two-dimensional array and look at things there. So the tourist code might be handy for that because we actually drew a two-dimensional grid by reading from an array and doing stuff there. So I think what you need to look at if you want to look at the line by line thing is go back to anything where we did a while loop within a while loop, and that's going to be the kind of structure you need to be able to go from a line which is a single line of pixels to multiple lines, because a single line of pixels is just a while loop across. But if we repeat that line in multiple places, then we're going to be able to draw a box. So I think that's the answer to your question. I apologize. I don't know the Chinese characters. I don't know. I don't know how to how to say what your name is there in the login. The person's asking about that. I think it's the same person was also asking about should we use things like end of file or pointers in the assignment. Um, Pointers you don't need. We've designed the assignment so that you don't need pointers at all. Um, you will sort of be using them in a way in that you can pass your canvas to a function and you'll be able to make changes to the canvas, but that's a subtlety. We have talked about that a little bit in the lectures, and I think it's going to be talked about a little bit in the tutorials as well, but you can just think of it as you can pass your canvas to your functions and you'll be able to write to it. EOF as the end of input is something that you will need to use in that if we give you multiple commands in a row, I think maybe up here in input commands. Oh, I don't have an easy place to show you, but if we were to give you these commands in a sequence, you would need to know when the sequence ended, and the sequence is going to end with an EOF. So there's been, I think, a couple of lab lab exercises that do that. Some of those lab exercises might even have their solutions available already, but either way, being able to read from input until you get input that is an EOF, and we can use things like scanf for that. We can use things like fgets for that. We can use things like getchar for that. All of those are going to be able to detect when our input is finished and be able to say, okay, this is no longer the valid inputs that we're looking at, so we need to stop there, and that's it, over. So I think, yeah, pointers you don't need, but to be able to use reading input until EOF, that's something you will need. Yeah. Okay, let's see what other questions we have here. Paul's asking to clarify if a command extends past the canvas boundary, the command is aborted, not just the portion of the line, square, ellipse, etc. within the bounds. Yes. Oh, sorry. Tom wants to say something.
True for line and square.
Yep.
Ellipse not true.
Right.
Ellipse
Gets
off by the edges but can stay.
right. Okay. So Paul, the answer to your question there is if it is a line or a square and it tries to draw anything outside the canvas, um, the entire command is aborted and nothing should be drawn. The ellipse is different. The ellipse will draw no matter what. So if part of the ellipse goes off the edge of the canvas, the rest of the ellipse will still be drawn. So slightly different rules for both of those.
Copying is the same as squares
Oh yeah, copy paste is similar. So if copy paste, if anything in the two regions is off the canvas, then the whole thing doesn't run. I mean, and that would be really awkward if it did. So if you're copying from off canvas and trying to paste it onto canvas, it'd be like, what? What are we reading from? Oh yeah, you have to uninitialize the canvas where you're pasting to. I don't. That's not possible. Okay, so let's not try to get too confusing with that. But yeah, so the reading and writing is going to be like that. Okay. So Paul's also asking, you're still confused about arrays in functions, and saying that the copy command that I wrote, let's go back to it here, is referencing the canvas and is able to write to the canvas. So this is that thing that I was talking about in the last lecture when I introduced pointers for the first time. We are going to get deeper in that, but for assignment 1, you can just make this assumption. When you give an array to a function, you have full access to the array. When you give integers to a function, you don't have full access to those integers, you only have their values. So in this case, we can actually make changes to this this two-dimensional array if it's given to us. And obviously, we're not doing anything because it's not in our main here. But if I was to give a canvas to this, we would be able to make changes to it. Yeah. Um, there is a video that Andrew has made about what the deal is with arrays and functions and things like that. Um, we are going to make that available to everyone so that you can see it. Andrew, you could probably link it in the live chat for the moment, but that's not the only place we're going to put it. We're going to make it available for everyone to see at some point. I'll put a notice up or something like that. Okay, we've got 10 minutes left. There's one thing I did want to talk about because it was a question that came up a lot on the course forum, but I think we've got one last question from Anton here, and I'll answer that, and then we'll go on to this thing um, that that I wanted to talk about. So Anton has a question about style. You have a lot of variable declarations in your main, about 15 of them, for different functions. Would you recommend storing them in arrays instead? Um, I would only store something in an array if it's a specific collection of things that belong together. So the only reason I would store something in an array is if it was like um, uh, identical collections. So for example, if it's like um, I actually can't think of anything in CS Paint where I would store the variables in an array and not name them. Because even if I was like doing like a two-dimensional array for something, which is the first one's rows and the second one's columns, I would still prefer to name one of them rows and one of them columns for readability later on. Otherwise, it's like this thing 0, then this thing 1, and it's like which one was which, and then you get really confused when you're doing your maths later. Um, the the only time I think I would do something in an array, which was like say I was doing like we were doing like in the lectures, the scores for a few people in a game, and so all of those things are scores for people, and they're accessed via the person's index number. And each player in the game has an index number, and you can access this information. That's the time I'd put something in an array. Or, like the canvas, where it's like every pixel is basically identical, I would store that in an array. I have no problem with you having 15 variables in your main. Um, yeah, so you're asking about you need to pass a whole bunch of arguments into something like a drawLine function. So you need to pass the canvas, you need to pass the starting, you might need to pass the direction, and you need to pass how many things are going in. Is that 4 different things? Even more than that, because some of those are double. Some of those are row column doubles. Not doubles. Row column pairs of integers. So I've got to be careful with the language whenever I'm talking. It's okay. It's totally okay. Look at this one here. I've got 5 inputs into this, and this one isn't even as complicated as I think the number of inputs that you'd need for a draw line. You said you had 15 variables going into one function, is it? Or were they for different functions? Because if you have 15 variables going into one function, I think that something's up there. I don't think there's anywhere you need that much information. But I have no problem with you just going, look, this has got 5 things going into it, and I don't mind that at all. Um, Especially because these are kind of in pairs. Like this is kind of one variable and this is kind of one variable, right? Oh, 15 in total across all the assignment stages. That's no problem at all. You got 15 variables in your entire assignment. That's a reasonable number of variables to have in your assignments. I would not be afraid of having 15 variables in your main for all these different things that you're doing. Um, it might look weird to you, maybe because are you declaring them all at the beginning? Because if you're declaring them all at the beginning, it might look weird to you because you get this massive pile of them. You could just declare them as you use them, like declaring them at the last minute before you need to use them. That's okay as well. There's no problem there. I actually feel like chances are you don't have a problem at all, Anton, because everything that you're saying so far seems like I would expect most people, if they've done several stages of the assignment, to have lots of variables. And I would personally, when I'm writing code, I don't count how many variables I have because I use them when I need them, and I know that I need them so that another variable must exist at that point in time. Okay, one thing that I wanted to talk about, and this is something that was coming up a bit in questions um, on the forums. Um, which thing was I going to? I was going to draw something. What did I used to use? Was it GIMP? Maybe. Oh, it would have been Xpaint here. GIMP is like super full on. All right, let's just not. Strangely enough, as you've seen from my art before, I'm not actually an artist, so maybe it's in here. Xpaint? No, maybe graphics. Xpaint. There we are. Yeah. Okay. So one question, and this is going to be the last thing I talk about. So one question that we were getting a lot in the forums was how to deal with an angle that's uh, larger than 360 degrees. So let's see if that's right. Okay, good. Oh, there's no Control Z in this. That's weird. Okay, so let's draw our possible directions here as if it's a mathematical kind of thing. Um, so here was our 0 degrees. Here is our 90 degrees. Here is our 180. Ooh, and here is our 270. So in our basic directions for how we're going to go up, down, left, or right, we're just looking at numbers between 0 and 359. So all of these, we're not even ever going to get 359, right? Because we're only going to give you exact values. And so we can have also 45, 135. This is for whenever we're using diagonals. So if you get to the stages where we're doing diagonal lines and things like that. Um, which one's this one? 225? Yes. I don't remember these off by heart. And 315. This is the hilarious mark of the computer scientist once they reach a certain level of their career. Basic arithmetic is no longer something that I consider worthy of my time, and so I don't even do back of the napkin maths like this to get this. I had to get Tom to tell me what the numbers were because it's just like no, the computers do that kind of thing. Okay, so the question is then, if I get a number that's higher than 360, what do I do? So let's say I get given a number. I'm going to do it in red. 450. So if I get the given something that says 450 degrees, what it's going to do is it's going to go 360 degrees around to there and a further 90 degrees around to here. And so my 450 degrees is going to end up here. So a lot of people were wondering, how do we actually deal with that situation? Because we might have, if we're looking at our code um, and we're picking directions, we might have something where we're picking directions really explicitly. So the way we're picking directions is like it's either 0, 90, 180, or 270. So those are my four directions that I'm just going to draw the original straight lines in. So if I'm doing my original straight lines in only those directions, and someone gives me a 450, it's like, well, the 450 doesn't fit into my if statements. What do I do? And so the first thing is like, oh, that's cool, that's cool. We'll just add if 450 into it, and it's like, maybe. And then you go further, and then you go further, and then you go further. And I don't know what this number is going to be, but this is a really big number. And we can't just keep adding if statements for this. So we want to be able to deal with any number that's higher than 360 to bring it back down into the range of 0 to 360. Actually, 0 to 359. That is still going to give us good direction out of this. And the answer to that is going to be mods. So using modular, remind you the definition of what the mod is. If I have, and I've got one here, so int z, I'm just kind of making up things here, is equal to x mod 3. And I'm going to say z will be the remainder when x is divided by 3. Let me take this one step further. Let me take it one step further. What does that give us? Isn't that an interesting potential proposition there? If I was to take the number 450 and divide it by 360, it's going to go into 360 once with a remainder of 90. So 450 mod 360 is equal to 90, which means it puts it back in the range that we're using here. So we can use stuff like mod to take something that can go way, way out of the range of numbers and bring that back into the range of numbers, but keep its kind of offset of how much it went in its sort of final rotation here, so that it ends up exactly in the same angle that it was going to be when it was like kind of spiraling around many, many times like this. You may recognize this because one of the earliest things I did with mod in the course, was only like maybe a month ago, was doing this with dice rolls. So if someone gave me a dice roll that was massively, massively high, I was going to use a mod to bring it back down into the range of 1 to 6. But what's cooler than just bringing it back down into the range of 1 to 6 is if we considered it to have gone around multiple, multiple, multiple times like that, like this one does, the 450 that stops here in the same direction as the 90, if we mod this with 360, ends up back at 90 exactly, and then that's how we can get those directions where the number appears to be way beyond what we expect, the 0 to 359, but we can actually just get there with that. Okay, we've gone a little over time. We started a little before time as well, but what I'm really happy with is that we've answered nearly all the questions. John Aspite's got one last question. Confused about shading, don't really know how to do it. Um, I'm going to give you a really quick answer to that before we wrap up the stream. So the deal with shading is it makes a change to the color. So the deal with the shading is I can give you a number with a shading, which is going to add something to the current color. So the current color is going to start off at black. So the current color is 4, it's black. Um, and I want to change the shade. So what we would do is if I give you a number, and there can be a positive or negative number, what that does is it changes what the current color is. So for most everything before you've gotten to this stage, your current color is always black. So you're drawing a 0 on top of 4s. Changing this color is actually the same thing as in something like Xpaint, where I just simply pick this color and I've changed the color to this, and now when I draw, it draws that color instead of the color that I was doing previously. The trick with the change shade is it will take whatever color you had and it will darken or lighten it by that value, and then that will be the color that you draw for all of your line and square stuff that you were having before that. So what the change shade command does is it adds or minuses a certain amount to the color that you're using in your drawing pen, if it was like a virtual pen. And then from then on, everything that you draw will have that change in color. I'm not sure if that's enough, John, but we're out of time. So I think if you do want more information about that, you can always check out our help session or ask a tutor about it, and they may be able to explain that with a bit more time to explain it. Alrighty. That's it. We're going to wrap it up there. Thank you everyone for coming along to the live stream, and I hope we've got a lot of useful information here. I hope this clarifies a bunch of things and helps people get further along in the assignment and get a better understanding of what they were going to do with it. We'll probably be doing one more of these during the second assignment, and we might, depending on demand, we'll see what people want, do another one in the lead up to the exam as well to help people with study. But from that, I will see everyone on Wednesday for our next lecture. Or if you're watching this at some other time, then I hope it was helpful no matter what. See you later.